Hello Finland friends, and welcome to the very first episode of a new video show. I've decided to name it Fix or Bust, and I guarantee that it will revolutionize the way you look on electronics and perhaps even life itself. In this show we will hopefully... Mamma? Nej mamma, nej. Inte fix your bust. Nej, jag håller inte på med snusk på kvällarna. Nej, du vet. Nej, gå och lägg dig du. Ja, godnatt mamma. Yes, welcome, Fix or Bust, a show that will explore the DIY side of life. We will be focusing on electronics projects and fixing broken stuff found at home, online, perhaps even in the neighbor's dumpster if we are lucky. Occasionally, I might even display some of my barely existing mechanical skills. The astute among you have already figured out that this is just one big scheme for me to be able to sneak down to the basement and drink beer. And we will hopefully enjoy a lot of beer together. Let's celebrate this first episode with a sour IPA from the Austrian brewery Bevog. So cheers and welcome once again. Don't let the snappy introduction fool you. You will be staring at virtually the same camera angle for the better part of the next hour if you endure. So stick around, it'll be fun, I promise. Let's not waste any more time. Let's take a look at the junk of the day. The patient on the operating table today will require this exquisite anti-scratch mouse pad. It looks like this. A very shiny box, sorry for any glare, and this is actually just a very cheap Chinese generic power supply. No manufacturer name on it, but I think the original manufacturer is called Shenzhen Sunlight Power, but it's sold under many brands on AliExpress, and that's where I got it. The model number is S-1200-60, and that gives a lot away. It's a 1200 watt 60 volt power supply, so 20 amp capable. The reason I got this one is that a while before I ordered one of these. This is a little programmable power supply from a company called RD Tech, and it's also available from AliExpress. If you've been following the EV blog on YouTube or other video platforms, you have quite possibly seen this one featured already. Not sure about this particular model because they come in various different flavors, different power ratings, voltage ratings, and so on. But there has been one or two videos posted about a badly placed capacitor that eventually exploded. Not sure if I'm affected or not. I think I checked that when I first received and built this because it came as a kit. But honestly, I can't remember right now if the capacitor was there or not in my unit. It has already exploded on me once though, but that was just the input fuse when I turned it on. And it worked perfectly after replacing the fuse, so I have no idea exactly why that happened. This particular model is called DPS5020, and it functions as a buck regulator only, so it will take a DC input voltage and convert that down to any desired DC output voltage. No boosting, so that is why we need this relatively high voltage power supply for it. According to the specification, it needs an input voltage at least 1.1 times that of the desired output voltage. So in our case, 55 volts in for 50 volts out. Now there's a crux, because there is also a maximum input voltage rating of 60 volts. So we don't have a lot of span there if we do want to run this at the higher voltages. If we wouldn't, no problem, we could just choose a lower voltage DC source, but then again it would make little sense getting the DPS5020. You could just as well get one of the lower voltage models instead. I myself needed it because of the reasonably high output voltage and at quite high currents as well, but more on that topic later. My first idea for a power supply was to find something that was lying around the house, but the only thing I knew I had that was powerful enough was this. Hey you. I salvaged this puppy a few years ago. It was heading for the junkyard along with a few of its friends. Apart from a minor few issues like the voltage being a bit too high, that it has a knack for blowing fuses everywhere you plug it in, and that it weighs more than me, it would have been perfect. Just a bit too impractical even by my standards. The next step was to go online, so I went to my favorite supplier, DigiKey, and headed to the AC-DC converters section, did a parametric search on the minimum power voltage and current needed, ended up with a decent list of candidates, and I sorted on lowest price first. At the time, I think that this model here was the cheapest. I don't remember seeing this 120 volt one. This one is actually just a bit shy of the 55 volts that we supposedly need to run the DPS5020, but it is listed as adjustable. I checked the data sheet and it can be adjusted up to 58 volts, so we should be okay. But considering that I was after a very cheap setup, paying nearly 400 euro for a power supply for the DPS5020 that costs somewhere around 60 euro, I think. It felt like quite an awkward match. So I decided to give AliExpress a shot at the power supply as well. This search term here seems to be quite a reasonably selective one. And the one I ended up ordering is this one down here, listed at just under 70 euro. And when I ordered, I think that the price was just under 60 euro, something like 56. So the prices fluctuate quite a bit, but as you can see, there are a number of similar or even identical models available at a lower cost. So let's take a look at this absolute cheapest one. And it's yours for 46 euro, but that's not including an extra 20 euro shipping, at least to Finland. Yeah. So let's see if there are any even cheaper ones. This one here is listed at 58 euro and free shipping, so this is probably the cheapest one you can get. So I thought I'd make this video because there might be others out there who would find this combination interesting, provided that the risk of death or serious injury is reasonably low. I've been talking enough already, let's start opening this thing up. As for the case, it's actually okay, I don't mind it at all. No rust, looks well built. All the connections are made on this terminal strip over here, So that means we have mains as well as the outputs. That's one little problem because, of course, it's not a very safe way to connect the mains directly. So I will have to manufacture an additional front plate or similar for it and mount this IEC C14 socket. Either that or mount it inside a separate enclosure, but that would probably require more work to avoid circulating the hot air inside. One screw here and one on the back, and we should be inside. And it slides off like that. It hangs on two studs up here. Let's zoom in a bit. So mains comes in here and goes to what looks like a pretty underdimensioned input filtering section. There's 3 thermistors for inrush current limiting, and let's save a few cents on the fuse. No fuse holder, no HRC fuse, just the cheapest leaded axial glass fuse they could find. As for the rest of the input section, nothing unusual, except for what I already mentioned. It looks very, very basic. There is one film cap, common mode choke, and some class Y capacitors. Open up any decent laptop power supply and you'll probably find at least double the amount of filtering components. This thing might just be a bit noisy. And then we convert from AC to DC using a full bridge rectifier. I believe that's the industry standard way to say it nowadays. I'm quite surprised to find a pair of Nippon Chemicon caps here, because if these are genuine, then they'd make up a substantial part of not only the BOM cost, but even the end user cost. These are around €5 each, a bit lower in volume of course, but still, I wonder, are these perhaps salvaged from used gear or even counterfeit? But I really do not know if there is a market for producing counterfeit caps in Asia. If you have any information on the subject, then please share it. If we jump ahead a bit, we can see that the output caps are not a name brand, they are marked Tycon. I've never heard of them before, but they are green, so supposedly low ESR. Next up is the controller section, and I'm spotting something a bit unusual, or well, at least interesting, because it seems as if it is transformer isolated. We've got one transformer here and one right next to this heatsink, and I assume that the switch transistors are located behind it. And it's perhaps not unusual as such as a design, but I find it unusual for a design that aims for a low price point. On the vast majority of switch mode power supplies that I've seen, the controller section is mains referenced, and then it's isolated from the secondary side via the main transformer, and then gets isolated feedback from the secondary side through an optocoupler or similar device. So I don't know, maybe this is more common for industrial products, or I just haven't opened up enough power supplies yet. And actually it looks as if there is a third transformer over here, and that could be a current sense transformer perhaps. Apart from that, not much else, just the main transformer and a quite simplistic secondary side by the looks of it. Large choke, some diodes no doubt attached to the large heatsink, and a few output caps. I don't know if we will find any components on the backside at all, so we'll find out when we flip it over. Worthy of note, the heatsinks are placed in the correct orientation, no obstruction to airflow, so that's good. There are a couple of trimmers, one here right beside the output terminals, and I assume that's the output voltage adjustment.
and one here in the controller section. I won't hazard a guess to what that does. Perhaps we can deduce that later. As I mentioned earlier, this model does have a temperature controlled fan. I do not know if that means speed control or simply on or off, but if I remember, we can test that out later. I think that's it for the top side. Let's flip it over.
And the heatsink looks like it's screwed from the back. Okay, what will we find? Ugh. Blah. That's quite possibly the worst soldering I have ever seen. They've obviously either wave soldered or hot dipped this PCB. I'm not sure I could tell the two techniques apart because I don't think I've ever seen a side-by-side comparison. But they've missed a few spots here and there, and they look oddly symmetrical. Perhaps glue residue from a label, or maybe marks from a tool used to dip it in the solder bath. I really don't know, because I've never seen anything like that before. And then the large components are hand soldered in place, but it looks like they have done it using toothpaste and a potato. I will have to go over that with the soldering iron later, because I smell cracked joints all over the place. To be fair though, the rest of the soldering looks quite okay. The board has a sort of sheen to it, like conformal coating almost, but I don't expect that on a low-cost board like this. Perhaps this particular factory just coats everything anyways. Maybe it's cheaper that way than to selectively turn it on or off. Looking at the isolation, I really don't see anything too awful. There's good clearance here. We have a cutout here. They got a bit close with the traces. And there's another cutout slot down here. Yeah, nothing to complain about there, really. But I do see one little bodged resistor over here. And that one is, let's see, 1, 2, 3 here, and 1, 2, 3 there. And that one is supposed to be a resistor as well. So they've... oh! One little poor resistor has been maimed, and its legs are still sticking up from the PCB. That's just wrong. That's disgraceful. At least give the components a worthy desoldering, okay? Here they just didn't bother. They snipped off the old one and tacked the new one to the bottom of the board instead. And that's just real workmanship. As for the part numbers, they are very hard to read even off screen, so I will have to pause momentarily and then get back to you after checking them using some viewing aids.
Tore! Tore! Kan du komma och hjälpa pappa att läsa? Jo, nu kommer du hit. Annars blir du ute i gropen och sitta igen.
Okay, so I'm back. The main switching controller I see is, not surprisingly, this DIP16 package over here. It's marked KA3525A, and that's Fairchild, or nowadays OnSemi part. The datasheet is not very extensive. It just describes the chip as including all the necessary control circuits for a PWM-based regulator. But there are other equivalent chips out there, the SG3525 and the UC3525, and the latter, the UC, is a TI part, and that datasheet is way more extensive, so check it out if you want. A quick googling didn't reveal that many SMPS designs based on this chip, but it seems to be more popular when designing inverters. Why the choice fell on this chip for this design? Well, my guess is two things. It's very cheap and it's very common. And the other little DIP8 package is a standard LM358C dual op-amp. Only one circuit is in use, and the pins of the other one are completely unconnected, not even soldered down for stability. Hopefully that won't cause any issue. A quick look at the mains earth. At least it exists. It goes down to the case via the pads surrounding this screw hole, and it also snakes off to the center point between these two Class Y caps. Regarding the small transformers, it seems as though my initial hunch was correct. They are isolating the control section at first with this one, and then, so to say, unisolating it back to the switching transistors. And this third one does indeed look like a current sense transformer. Let's look at the voltage sensing. The positive side is tapped off here and goes through a resistor back to the control section, and the negative side is connected as well, goes to this nice little star ground point here. So, where does the power go? Rectified DC mains comes in here and goes down to the switching transistors and the current sense transformer, and then proceeds up to one end of the main pulse transformer primary, and then it goes nowhere because we seem to have a link. No, it's not a link, it's a capacitor. So that would suggest that this is sort of a half-bridge design. And I say sort of because most of the half-bridge designs that I've seen have been symmetrical, so they would have had a capacitor from either rail to the non-switching side of the transformer primary, but this one only has the single one up to the positive rail, and I don't know if that's like a viable variant of a half-bridge design or if this is just another cost-cutting attempt. Anything more before we slap this thing together? As you've seen, there's no secondary side regulation, but that's fine for my purpose at least. I expect the RD Tech to take care of that. Also, this enormous choke here on the output is a bit loose and wiggly. I think that it would benefit from some additional silicone to hold it in place, and that's a bit funny since it's advertised as for use with CNC machines and such. I would not trust this in any sort of vibrating machinery as it is. I think that this was all that I could squeeze out of the teardown. Let's screw this thing back together and start taking some measurements. Another very good reason not to work with mains directly on terminal blocks is because you will have to manufacture a cable looking like this. Do not manufacture a cable looking like this. If you decide to manufacture a cable looking like this, which I explicitly told you not to, please do not drink anything stronger than beer before you have secured the dangerous end to your terminal strip. If you do drink something stronger than beer, which I explicitly told you not to, you will only become forgetful. Plug in the pointy end first, grab one exposed lead with one hand and stick the other one where the sun don't shine, and that can only end up with a shitstorm. So, in short, don't. Let's pause and get things hooked up. And we're back. I did not manage to kill myself with the cable of doom, which means that I am entitled to a glass of whiskey. We won't begin taking the measurements just yet, because I wanted to go on to a little sidetrack first. I received this power supply from eBay a few days ago. It's just a regular 12-volt 100-watt power brick. It will be featured in an upcoming video, but I wanted to use it as a reference for today's measurements. As luck would have it though, it was dead on arrival, so the first thing I had to do was to open it up, which was not an easy task. I had to blast the sucker with Justin Bieber for half an hour before it gave up. It was not a pretty thing to witness, I can tell you, and now the case is all cracked and twisted. Poor bastard. But at least I now had access to its guts, so I started taking some measurements. And I measured it with the power plugged in, and there was no AC voltage across the full bridge rectifier. And so I unplugged it and measured continuity, and suddenly I had continuity all the way from the mains input to the bridge, and I replugged it, measured again, no AC voltage. I repeated that a few times, and suddenly it said bang and started working. That got me thinking, because the exact same thing except the opposite happened to an old laptop power supply of mine many years ago. It said bang and then stopped working. And what had happened was that one of the leads of a common mode choke had snapped right off. So I took a closer look on this one, and sure enough the same thing had happened. And it must have been purely by accident that every time I measured continuity with the power unplugged, I put pressure on the exact right spots for the two lead ends to make contact, but not when I measured it with the power plugged in. But I can understand it. I mean, when you realize that you're a small and insignificant part inside a small and insignificant power supply, who wouldn't snap from that? Now let this be a lesson, kids. Always check your chokes. So, back on track, time to start measuring. Now, I must admit, I haven't done any deep measurements of power supplies before, so take my comments with a grain of salt. And sorry, the audio will become a bit noisy now, because both the scope and the RD Tech aren't the quietest things around. Let's begin by looking at the startup waveform with no load. We're in 200 milliseconds time base and 10 volts per division. And we can count 1, 2, 3, 4, 5-ish. Make that around 1 second for it to get up to speed. We are seeing some ripple there on the end where the voltage has stabilized, but I would almost expect that given the no load condition and the lack of any secondary side regulation. But let's zoom in on that anyway and get a closer look. This is now AC coupled at 500 millivolts per division and a 20 millisecond time base. And as you can see, there is some ripple at 400 millivolts, but then some larger transients at each switch cycle. And the counter is scooting around at about 600 Hertz, but if we count manually, then there's 4.5 divisions per each switch cycle, and that would correspond to 90 milliseconds, so around 11 Hertz. Possibly the counter is thrown off by all the noise. Let's test the adjustment range. The switching is a bit erratic. There's frequency modulation as well, mixed in with the pulse width modulation, and you can see the short bursts in between the longer switch cycles. And you can probably hear this eerie ticking noise as well. I think it's... Did it come with... let me check the box. Yeah. Skynet inside.
Fuck you, asshole.
It goes down to more or less 0 volts, which is a bit odd since it's advertised as having an adjustment range of plus minus 3%. I think I'll stop at 56 volts. That should keep the DPS5020 happy without getting too close to the upper voltage limit. Let's move on and connect a load. I think I'll begin with the 5020 module itself.
I'll switch off the AC coupling, set it to single shot capture mode, and let's go. Oi! That's a dip. Down to around 30 volts before it started to ramp back up again. But at least it's not as slow as when starting up. We are using a 2 millisecond time base, so around 1.5 milliseconds before it starts to react. I assume that where it levels out there at 30 volts, that's when the output caps of the power supply have fully charged the input caps of the DPS5020. And that will make sense because there's 3 680 mic caps in parallel on the output and 3 470 mic caps also in parallel on the input, so they sort of balance out midway. Let's unplug the power and see what happens during shutdown. I don't expect anything too exciting based on how slow the voltage dropped when we trimmed it. Let's turn the DPS5020 off first. Nothing triggered there. I probably should remember to adjust the time base first before switching the power supply off. Okay, so ready to unplug it. A very slow bleed. I did spot something that I assume was a bleed resistor across the output caps, but it was hidden underneath a big load of silicone, so I couldn't check the value. Let's take a quick look at the other power supply just for comparison. The startup, way bit quicker. Not the same smooth taper that we saw on the other one. This one has a sharper knee and a bit of overshoot when it hits the target voltage. So obviously a more elaborate regulation solution in this one. So this one hit 12 volts at around 10 milliseconds. It's hard to do an apples to apples comparison with the other one, but a guesstimate would be that it would hit 60 volts after about 100 milliseconds or so. Let's take a look at the no load ripple. Not much happening there at all. Nowhere close to the same sawtoothy ripple as we saw on the large one, but this one obviously has secondary side regulation as well, so not a fair comparison. Let's switch the DPS5020 on. There's more things happening here, a more aggressive regulation going on. The initial voltage drop is around 4 volts, and then a few spikes and a bit of ripple before it swings back into place. Switching noise with the RD Tech on but no load. Let's move on and connect the load to the DPS5020. Here's an electronic load. I built it myself. I really like it. It's beautiful, it's modular, and the best thing is you can make yourself a snack while you're experimenting. One of these days I have to build myself a proper electronic load. Anyway, let's see what happens.
I've already preset the DPS5020 to its maximum output, 50 volts 20 amps, and the load.
Interestingly, we are not getting the full 50 volts output, only 48.8, 48.9 volts. Let's try to adjust the input. So the claimed figure from RD Tech of an input voltage 1.2
1 times higher than the desired output voltage turn out to be a bit optimistic. It's not out by far, but still, if you bought the DPS5020 and then went to look for a power supply and found one that maxes out at 55 volts, then you're toast. That's definitely one thing to look out for. Do try to find a 60 volt or higher capable power supply that can be adjusted down. And in that respect, this power supply that we're looking at today is actually quite suitable. As you can see, we are using up around a quarter of the available power. I'll try to see if I can find something more tomorrow to plug in, and I'll just write the results in that case. I was just about to finish off, but I wanted to show you this first. The fan is starting to come alive, but it's clearly not getting enough juice. This is one of those things that would be very easy to modify yourself if you got one of these, just to add a little PWM fan controller. We didn't take a look at the noise with the load applied, so let's do that as the last stop. It's not a very pretty sight, but that's what you'd expect with no secondary side regulation. And I think it's time to unplug the car heater, because there's a distinct smell of warm plastics spreading throughout the room. And as you can see, the output noise changed character quite a bit. But don't take this as an absolute truth, because my probing technique is probably for the birds, so there might be all kinds of crap contaminating this signal. I've been going on for far too long already. I think it's time for a final verdict. There's not that much I can squeeze out of it anymore. Well, I haven't done any death tests to it. Supposedly this thing has short circuit protection, but I wouldn't rely on it. If you want to see me try to kill this thing or take some other measurements, then just let me know. So what's the final score? Well, it's simple, it's crude. The soldering is crap, and the lack of secondary side regulation might not suit everybody. But paired up with the DPS5020, I think it's an okay combo. I don't mind it at all, and in some sense you perhaps even get more than you pay for. The real test will probably be the longevity. Will this last a good few years, or will it die in the coming week? I'll just have to wait and see. But in any case, I hope this video helped someone choose a power supply for their power supply. I promised earlier on that I would reveal the intended purpose of my purchase of the DPS5020, and the reason I got it is this. I bought myself a chainsaw, not the loud smoking type. No. It's a modern, electric, lean, mean tree-killing machine. Of course, I had to pair it up with a battery, so I got one of these. It's the BLI 20, and it cost around €160. Not wanting to stuff Husqvarna's pockets with any more money, I decided to get my own charging solution for it. And in case you didn't know, any decent programmable power supply is an excellent choice for charging lithium-ion batteries, especially if you can set a cutoff current at the end of charge. I don't know if any of the RD Tech devices can do that. I don't think that the DPS5020 can, with the firmware I've got at least. But as long as you switch it off manually reasonably soon after the constant voltage part of the charging cycle is finished, then you should be okay. The other thing I wanted to do was, of course, to get more battery capacity, and not for that ridiculous price. So I started investigating how to build my own battery packs and pair them up with a chainsaw. But I quickly hit a major obstacle, and I will quote the manual here. It's in Swedish, so you'll just have to take my word for it or translate it yourselves.
Only use the BLI batteries that we recommend for your product. The batteries contain encrypted software. And so I thought, that's a bit ridiculous. I want to be able to use my own battery packs with my chainsaw. So because of this, I can almost certainly promise you that we will be taking a look at the best solution to this problem in a future video, or perhaps even a series of videos. Well, it's about time to say goodbye, I think, but before I leave you, I thought I'd give a sneak preview of what's in store for an upcoming video. And since this is my first ever video, I'd love to hear your feedback. Should I pursue this career and make more videos, or am I better off moving to Montana and becoming a dental floss tycoon? Let's move on to the beginning of the end. This might give a little hint. I hope I can get the box to fit. Now, jeez, no, I will have to do something like this, perhaps. Well, it's certainly big, sorry. I don't think I can make this work any better. Found this on eBay, and either it's an absolute steal, or I'll be lying on the floor crying, absolutely devastated in a few minutes. Packaging, oh, packaging, more packaging, and what is it? Well-wrapped dead hamster, perhaps. Tut, 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 tut. Now, that's not a camera. This is a camera. It was listed as 4 parts, not working. Possible impact damage. And the only sign of possible impact damage was that the menu knob was missing. So, what do you say? Should we... How do you even get this one on? Just plug it in. See if we get anything on the screen. Where do you go? That lens is not really worthy for this camera. Unfortunately though, I don't own any cinema lenses. But if this thing works, or if I can get it working, I might just get one. So that's what the plug pack, the smaller one, was for. And on. I hear something. I hear a fan. Anything on the display? But we have something